So here we have an arithmetic progression, and it is given that the sum to the mth term has a value of n, and the sum up to the nth term has a value of m. We need to prove that the sum up to the m plus nth term, that's equals to negative of m plus n. So let's prove that. First, we'll have to specify the first term and the common difference. So let the first term be, so we're going to represent the first term by the letter a in lower case. Similarly, we'll also represent the common difference in lower case. So this is going to be represented by the letter d. Now that we have the first term and the lower and the common difference, we will use the formula for the sum up to the nth term. So this is the general formula given by n over 2 multiplied to 2a plus n minus 1 multiplied to d. So using this, since we are given that the sum up to the mth term, the value is equals to n, and the sum up to the nth term equals to m. So here we can use this particular formula to rewrite the sum up to the mth term as m over 2 multiplied to 2 times the first term plus, since we're considering the mth term, so we're going to have m minus 1 times the common difference d. So this is going to be equals to n. Multiplying both sides with 2, so we'll have m multiplied to 2a plus m minus 1 times the common difference d. So this will be equals to 2n. So let's label this as equation number 1. Then the sum to the nth term, this is going to be equals to n over 2 multiplied to 2 times the first time plus n minus 1 times the common difference d, having a value equals to m. Multiplying both sides by 2, so if n multiplied to 2a plus n minus 1 times d equals to 2 times m. So let this be equation number 2. The next step, what we'll do, we'll subtract equation number 2 from equation number 1, such that we have m times 2a plus m minus 1 times the common difference d minus n times 2a plus n minus 1 times d equals to 2 times n minus 2 times m. So let's further simplify. So here we will have, let's multiply m with each of the terms within the parentheses. Oh yeah, so you have 2 times am plus m times m minus 1 times d minus 2 times an minus n times n minus 1 times the common difference d, which will be equals to positive 2n minus 2m. Now we have, if we take 2a as the common factor, so we will get 2a multiplied to m minus n plus, we'll take d as the common factor for the second and the fourth term, so we will get m multiplied to m minus 1 minus n multiplied to n minus 1 times the common difference d, which will be equals to 2 times n minus m. Now we have 2a multiplied to m minus n plus, so we will multiply m with m minus 1, so we'll get m squared minus m minus n squared plus n, all multiplied to d, so this will be equals to 2 multiplied to n minus m. Now we have 2 times a multiplied to m minus n plus, we'll take m squared and n squared, we'll combine them, so combining m squared minus n squared is simply m minus n times m plus n, and combining negative m and positive n, we have negative of m minus n, which will be equals to, so we'll take negative 2, this will get multiplied to m minus n. Now we can pull out m minus n from the first term and the second term, and this is going to give us 2a plus, so within the parentheses we're going to get, so here there's a d missing, so we have m plus n minus 1 all multiplied to d. This is equals to negative 2 of m minus n. So we can factor out m minus n from both sides. That means we'll have 2a plus m plus n minus 1 whole multiplied to d, that's equals to negative 2. Now we'll further simplify by multiplying both sides of the equation with m plus n. So we'll multiply with m plus n, and this is going to give us m plus n multiplied to 2a plus m plus n minus 1 times d. This will be equals to negative 2 multiplied to m plus n. Now we'll divide both sides by 2 to get rid of this 2 on the right hand side. So we will have m plus n divided by 2 whole multiplied to 2a plus m plus n minus 1 times d equals to negative of m plus n. Now what is this? This is nothing but the sum up to the m plus nth term. So sum up to the m plus nth term. So we obtain that this value is equals to negative of m plus n. And this is exactly what we have been asked to show. Hence we have successfully proved the following.